next concept is potential energy. What is potential energy? So see here, if I take a rubber band, we know that rubber band, take a rubber band and hold it at one end and pull from the other. So this is the rubber band. So hold it one end and pull from the other end. So the band is stretches. Okay. Release the band at one of the ends. So release the bands at one of the ends. What happens? The band will tend to regain its original length. Obviously, the band had acquired energy in its stretched position. So how did it acquires energy when stretched? So see here, in this situation, energy is stored. Okay, energy is stored due to work done on the object. Here the energy is stored due to work is done on the object. The stored energy is transformed. Okay, the stored energy is transformed and that energy is called potential energy. Okay, here the energy is transformed to the band is its potential energy. So now how do we define the potential energy? Potential energy of an object is the energy present in it by virtue of its position. Okay, the potential energy of an object possessed or potential energy possessed by the object due to its position. We simply defined as due to its position. Due to its position is called what? Potential energy. Okay. So now this potential energy can be represented in equation. So how do we represent? See, for example, if we take the object of mass m. So for example, this is the ground. So here the object is placed here. Its mass is m. Let it be raised through some height. That height is h. Okay. From the ground. So this object is raised through this height h. A force is required to do this. The minimum force is required to raise the object, which is equal to weight. Remember that the minimum force which is required to raise this object from this position to this height. So this is called what? Weight of the object, and this is represented by mg. Okay, the object gains energy equal to the work done on it. So this weight is always equal to energy. Okay, we know that the work done is defined as force into displacement. Here force is, that means here this is the mg. So this is weight, but this weight is always equal to force. Okay, so this is force is always equal to energy. We know that. Remember that force is always equal to energy, and energy is equal to weight. So W is equal to, so here this is the work done. Okay, this is work done. So W is equal to force into displacement. Here force is mg. Displacement is, how much is displaced? H. So H. So work done is equal to mgh. This work done is always equal to energy. That means here the potential energy is equal to mgh. Okay, remember that. So once again I repeat here. So here the object is at ground. When it is raised to some distance, that is h, some height, it is represented by h. So this here the object will require some energy or minimum energy to rise this object through a height of h, that is always equal to weight. The weight is equal to m into g. Okay, this m into g is always equal to force. Okay, so in the place of force, write the mg and h is h. So w is equal to mgh. W andre, so w means work done. So work done is equal to always equal to energy E. So potential energy is equal to mgh. Okay, so one more thing is there, that this potential energy is always depends on position of an object. That means its initial position and final position, not its path. Okay, it always depends on position, not its path along which an object is moved. You should remember that the potential energy always depends on initial and final position of the object, not on the path along which the object is moved. Okay.